Hello everyone, how are you?
Assalamu alaikum, sir.
Sir.
So this is the review class. We have already finished our syllabus. So today there will be only review. So I'm going to give a brief about the slide which is actually syllabus for the CT4. And you guys know in the last class we have our CT4. So it is actually in Wednesday. So if you have any queries, question on any confusion on any topic, any part, you can let me know.
Sir, কোনো counseling outside দিবেন sir?
Counseling hour is whenever you need, you can email me.
Okay, sir.
Okay. And there is an exam is on actually 3rd of October,
Ji,
right?
sir.
In the next month, exam is on actually 3rd of October, which is Sunday. Okay, if I see it is Sunday. So on Saturday, 2nd of October, I'll be available for you guys from 9 to 11 p.m. or you okay if you want to study first and then come to the counseling hour. So it's better if I give that during the class lecture time. Okay, so from 2 p.m. to 4 p.m. Okay, I'll be available in that time because I guess you'll all study in that day during the morning. And in case you have any problem between 2 to 4 p.m., just knock me. I'll be there in a counseling link. Okay, in case you need. So just wait. I'm going to start today's lecture. Okay. So in this memory organization slide, we have seen many things. Okay. First, two things which is really related to our assignment, and I'm not going to actually disclose the solution of the assignment in here. So assignment deadline is actually 29th of September. Before that, you have to actually submit on that day actually. So in that assignment, you have to find out about the locality as well. So I'm going to give you a brief about the locality in here as well, so that you are prepared about the class test as well as the assignment. Remember, this temporal locality is all about same item again and again. So you have to try to find out in your assignment if something is getting accessed for multiple times or not. If something is getting accessed for multiple times, then it is temporal locality. And if there is something for which more nearby items are there, and for that it does help or not, doesn't even matter. If there is any change in the misread hit rate due to this type of localities, we have to find whether some items are getting accessed multiple times, or because of more or less item, is it affecting the solution or not. So definition of temporal locality is those items we are accessing currently, we can access that soon, so we have to store them in cache memory. And special locality is those items we are accessing now, maybe nearby items we are going to access them soon. So you have to apply yourself in the assignment to find out which locality, or is it both or is it none, what is the answer in the actually assignment. Okay, assignment question is that, let me show you again slide number 33, question B and C. This is the assignment. Okay, so I'm going to give you a brief again about this slide, what we have seen. So we have seen the localities, then we have seen memory hierarchy, that processor is directly connected with only cache memory. So if something that is demanded by the processor or the user. Whenever we demand something, that request directly goes to the processor, and processor process something so that we can see that required thing what we actually requested to the processor. So processor directly connected with cache memory. If something is present in the cache memory, it can access them faster, so it is a hit. If something is not present in the cache memory, uh, the access time will be much more long, or we can say slower, then it is actually a miss if something is not present in the cache memory. Because we have to look for that in the lower part of the memory, like in RAM or maybe in hard disk. So we have to find it there, and then it is not that from there it will directly go to the processor. It is going to go to the processor by covering this step, memory hierarchy. If something is found in the hard disk only, then it has to go to RAM, then to cache, then to processor. So it will be a long delay. If something is not present in the cache, so it is a miss. If something is present in the cache, it is very fast. We can access that, and that is a hit. So we have seen what is hit. Access data present in upper level is hit. Excess data absent in upper level is miss. And we have seen what is hit rate, hit time, miss rate, miss penalty is in here. Miss penalty is much more bigger than the hit time. Okay. And we have seen direct map caching as well, how we can actually cover multiple blocks of the RAM within less blocks of the cache memory. With this direct map technique, we have seen mathematics as well, where it was 8 blocks and 1 word per block. We cannot store 1 word per block. And if there is some block which is missing, we have to copy that onto the memory. Valid bit will be guess. We store the tag in here as well as the data. So we have to find out for a word, missing word or requested word, is it hit or miss, in which block it is going to go, and update that block. Okay, then we have seen if something arrives like this, 18, where it wants to go to a block 2 where 26 is already there. As it was one word per block example, so we had to replace that word with 18. So this is what we have seen. And then we have seen the block size considerations as well. Then we have seen the formula for tag. We tried to understand this formula, not to memorize these things. Then we have seen this formula of cache, size of the cache in unit of number of bits. And remember, I have already said that you should only write the formula and replace n and m with their values to find out the total size of the cache. Never try to find out the exact size by calculating the multiplication, addition, and or anything. Okay, is it clear? Please respond
Yes, sir.
about the cache. Okay, fine. And then we have seen if a byte address is given instead of the word address, how can we actually find in which block this byte will go? Out of 64 blocks, this byte was actually going to block number 11, and we have to find this in two steps. Two steps. First step is actually block address, which is the byte divided by the number of bytes per block. Even that is 4 words per block. In the question, if that is given 64 blocks in the cache, 4 words per block, even that would have been 16. Why? Because we have to divide it by bytes per block. Because this is a byte, we are going to divide it by bytes per block to get the block address number. Now, when you get the block address number, we have to find the block number of how? 75 mod 64. Remember, mod is the result of the remainder. If we divide 75 by 64, then we get the modulus result, remainder as 11. So this is the memory field. It consists of tag plus index plus offset. Index is 2 to the power n. The n is index 2 to the power 6, 64 blocks. So n is 16. Index is 6 bits, sorry, 6, not 16. And offset is m plus 2. M is 4 words per block, 2 to the power m. 2 to the power 2 is equal to 4. So m is equal to 2. So offset is equal to m plus 2, which is 4. And we have seen the tag bit should be actually total bit minus the selection bit. Selection bit is index plus offset in here. Then we have seen, then given this memory field, we can find out how many uh, words per block is in there, how many cache entries in there, like how many cache blocks in there. We can find these things as well. Now, there is that mathematics that we have seen to find out the number of blocks. We have to divide the total size of the cache by words per block. Okay, then we have to find m with this word per block, it is 2. Then index 15, tag using the formula, cache size using the formula. Okay, then we have seen this big mathematics where we have to find out the miss rate for given addresses, byte addresses. We have seen 12 is miss, 42 is miss, and for these misses, using these two steps, we can find out the block number and miss or hit. We have to find out what address is being copied in the cache memory due to a miss. Because of a single byte miss, there will be two words in the block. So 8 bytes, 2 into 4, because one word is 4 bytes. So there will be 8 bytes. Which 8 bytes? These 8 bytes. Using that formula, we have given in the class lecture. Block address into number of bytes 2, block address into number of bytes plus number of bytes minus 1. Okay, simple formula. Try to keep this in mind. So 1 into 8, 8, 2, 8 plus 7, 1 into 8 plus 8 minus 1, 8 plus 7. And for 42, what address should be copied? Is it hit or miss? And then these addresses will be next time hit, if not replaced by some other address. It will always be hit. 40 to 47 will be hit. 12 to 15, sorry, 8 to 15 will be hit. So 7 is missed, for that we copy 0 to 7. 39 is missed, for that we copy 32 to 39. Miss rate is 4 by 6, 4 by 6 into 100%, that is the miss rate percentage. Okay, then we have seen theories like what is write through policy, what is write back policy, and then we have seen this mathematics in here, miss cycle per instruction mathematics to find out the miss cycle per instruction for ICAS, DCAS, and the actual CPI as well. All these values will be given in the question. We may have to find out the miss rate from some question, and then average memory access time, all these values will be given. Maybe the miss rate we have to find it from some other math, and then we have to find this thing. So this was the review for the entire lecture in brief. So you guys let me know if there is any confusion in any part of the slide. In case there is a problem in any part, in any question, you can let me know. Okay, I'm going to give you a task. Give
স্যার
you a task. Yes, yes, yes.
স্যার ওই যে ন্যানো সেকেন্ডের ব্যাপারটা এই যে
Okay,
টু
okay, okay,
সাইকেল
okay. This one. Okay,
ইয়েস
I'm
স্যার
going to explain this in here. Okay. CPU with what clock it will be given in the question. And in average memory access time, we find the answer always in nanoseconds. Whatever the hit time is given, whatever the miss penalty is given, the result will be in the unit of nanosecond, always nanosecond. So if the CPU is 1 nanosecond clock, so 2 nanosecond will give 2 clocks. 2 clocks mean 2 cycles, clock cycles per instruction. So if that is, for example, 2 nanosecond clock. So in 2 nanosecond, we generate only one clock. So our answer is 2 nanoseconds. So it will be one cycle per instruction.
স্যার এটা
Is
যদি
it
3
clear?
ন্যানো সেকেন্ড থাকতো
For example, it is 3 nanoseconds. Then how we are going to find this value? We are going to divide 2 by 3. That would be the cycle per instruction. But remember, in here you are never going to find a fraction, because cycle per instruction cannot be fraction, right? It is always to has to be a decimal
তাহলে এটা
value.
ওয়ানই হতো স্যার।
No, it can be like this. For example, if that is 0.5, then 2 divide 0.5, it will be 4 cycles per instruction. Right?
Yes, sir.
Like this. Okay, so divide this value with this value, you are going to get the number of cycles in here.
Okay, sir.
Okay, so this is it. So I'm going to give you a task now to complete. uh, Let me give you that task. Let me find that question for you. Just wait. Okay, I'm going to share a word file with you guys instead of this, and you have to find me the answer of this. Can you find the solution in here? We have to find the miss rate in here. Let me check. Yes, miss rate. Consider a cache memory size of 2 KB, block size having 8 words per block. Determine the miss rate if the following bytes are addressed sequentially: 10, 15, 20, then 200, then 204. Okay, find out the result. Try to find out the solution. Take some time. Try to see the slide, how it is done. Then try to find out the solution. If you cannot, I will help you. So take 20 minutes from now and try to find the solution. What is the progressing there? Anyone finding any values? Anyone want
Sir,
to?
misread 2 out of 5.
Can you please write it down your mistake in the chat box, Mohit? Mohit, can you please give me the answer for the amount of bytes copied for missing 10 and 200?
Yes, sir.
Okay, give that in the chat box. Others, please try to focus on his answers. His answers are correct up to now, I can see. One 92 to 223. Exactly correct. Arya Javan Disha answer is also correct. Arya Javan, your number of bytes copied are similar as well. Check Muhibal Hassan's answers are correct.
Sir, 32 bytes.
32 bytes, but which 32 bytes copied for 10 and 200 miss? Okay, I'm going to show you the answer. Let me find you the answer in here. Okay. So assume number 10 in here. Okay. If you want to do it for number 10, then what we have to find out for number 10? First, block address. Okay. Now, if we want to try to find out the block address, what is the formula of the block address? The byte floor of the byte divided by number of bytes present. 8 words means 32 bytes, right? Please respond.
Yes, sir.
And what is the result in here? 10 divided 32.
0.
Very good. 0. 0 is the result. 0 point something means 0 because we are going to take the floor in here. So this is the block address. Now we have to find out the block number. Block number will be number of blocks. Uh, block number will be 0 mod. Number of blocks is, okay, we have to find out the number of blocks first. And how we can find the number of blocks? Let me show you. 2 kb. So we have to take this 2 kb, 2 into 2 to the power 10, right? Please respond.
Yes, sir.
And we have to divide this number by 8 words. We have to divide this number by 8 words. And to do that, 8 is actually 2 to the power 3 into and we have to take it to bytes. So 1 word is equal to 4 bytes, so we are going to multiply with 2 to the power 2. So actually it is 2 to the power 11 divided by 2 to the power 5. So everyone has this block number 2 to the power 6, right? Please respond.
Yes, sir.
Okay, so it is 2 to the power. So if 0 mod 2 to the power 6, then what will be the result?
0.
0. So in block 0, now which words will be copied? What is the range of the memory address copied? Remember, block address into number of bytes per block. 0 into 32 is 0. 0 up to 0 into 32 plus 32 minus 1. So it is 31. 0 plus 31 is 31. Copied 0 to 31. Now for copied 0 to 31, 15 and 20 will be hit, right? Please respond. Just write hit, that would be okay. For 200, 200 is not hit. If 200 is not hit, then what we have to find out is first the block address. First the block address. Block address would be 200 divided by 32. And what is the result? Can anyone please tell me the calculation result?
0.
200 divided 32, not 10 divided 32.
6.
6,
6,
right?
sir. 6.
6 point something, so it should be 6. Very good. So now we have to find out the block number. Do that, we have to do this thing in here. 6 mod, it will be 6 again, right? Please respond. So what will be copied in here? What bytes is going to be copied? 6 into 32. 6 into 32. So it is 192 up to 192 plus 31, which is 223. So for that, 204 will be it. So this is the final result in here. Let me drop this one in the chat box for you guys. Okay, let me give the entire. This is the solution. It will not take more than 5 minutes for you to find it if you know the procedures. Okay, it will not take more than 5 minutes to find out 5 numbers whether they are hit or miss. It is take less than 1 minute to find out the number of blocks. Then you can find the other things easily. Okay. So everything clear? Please respond.
Yes, sir.
Okay. So the answer is given in the chat box as well. So this type of questions will be there in the class test for. So please find the answer of this type of question in the class 4 easily. Do not waste so much time. And we are yet to prepare the final question that is going to be moderated maybe after the Monday. So I am yet to know about this thing. I don't know what will be the questions in the final. What will be the format of the final questions? Okay. So if there is one from single cycle, two from pipeline, or how many from single cycle and how many from memory organization, I am yet to be assured of. Okay, so when I'm going to know about that, I'm going to let you know. Maybe in the next class on Wednesday, I'm going to let you everyone know about this thing, that how many questions from which section will be there. But normally for 25 marks, it is like that. Let me give you a brief idea. One question from single cycle, two from pipeline, and two from memory organization. There will be 5 questions for 25 marks, each carrying 5 marks. Okay, so this type of questions can be there. So prepare well for that. If you have any confusion in any part in memory organization, do please let me know. If you have any confusion. No confusion? Okay, so I'm going to stop the recording as well as the screen share.